Good afternoon. Today's topic is simple pendulum. We have studied this topic in class 11, science stream. This topic you will again find in first year course of diploma engineering, first year course of BTech. Then again you will find the same topic, simple pendulum. Again is the subject of theory of machines in mechanical engineering course. Then again you will get the same topic, and this topic I think is very interesting for the students. Simple pendulum. What is the arrangement? A thread is there. Say it is hanging from the ceiling, and at the end of the thread a spherical mass is attached. Okay. So if no force acts on the bob, then there will be no movement. It will be in static condition. And when it is in static condition, if you consider only the bob, that spherical mass is called bob. If you consider only the bob, then two forces are acting together on that bob. One force is acting in the downward direction and one force is acting in the upward direction. Both forces are of same magnitudes and they are opposite in directions, result of which is zero force on the bob, and that's why the bob is in static condition. What are those two forces? One force is the weight of the bob itself, which is acting in the vertically downward direction, and second force is the tension in the string, which is acting in the vertically upward direction. Say tension in the thread is denoted by capital T. Here not capital T, here you will use S, capital S. Okay. Later you will understand why I am taking S here. S is the tension. So when it is in static condition, S is equal to mg, where m is the mass of the bob, g is the acceleration due to gravity, small g, value of which is 9.8 meter per second square. So in static condition, S is equal to mg. This is known to you. Now, say this is the bob. This one is the bob, and this is tied by a string. Now, if you move this bob in this direction, what will happen? It will not move in the horizontal direction because it is tied by the thread. It will it will move along a curve, circular arc, right? Radius of which is equal to the length of the thread plus radius of the bob. The bob is spherical, or radius of the bob. Okay? Radius of the bob plus the length of the thread is equal to the radius of the arc along which the bob will move. If you pull it by using your hand in either direction, either right or left direction, okay, it will move along a circular arc, and somewhere you take the bob. You just take care of one thing, that now the position of thread is inclined. Okay, it is not vertical; it is inclined. This new position of the thread makes an angle with the vertical. Say that angle is theta. This inclined, this vertical. So this angle is theta. You do one thing only for this case, for this class. that theta should not go beyond 4 degree. If theta go beyond 4 degree, then the mathematics will be somewhat complicated, means another mathematics we need to use. Okay? The mathematics which are going to use here will be applicable only when the maximum value of theta is 4 degree. Just keep in your mind this. In the next class I'll explain if theta exceeds 4 degree, then what will happen? Which mathematics we need to use for that case. Okay? For this case, maximum value of theta is 4 degree. Now, whenever you have taken the blob in a new position along the arc, okay, that means, so this was the mean position, the static condition, this is the mean position of the blob, and you have now taken somewhere here. So, what happens? This is the horizontal line, and the blob is somewhere here. That means the blob, you have raised the blob to some height. That means the blob has now gained some potential energy due to the change in elevation, due to the change in height. Say through the main position, you draw a reference line which is horizontal, of course, and that is your datum with respect to which you are going to measure the potential energy of the blob. Okay? So this vertical height, if this vertical height is small h and mass of the blob is m, then mgh is the gain in potential energy. Right? mgh is the gain in potential energy by the blob. Now, from that position, if you leave the blob, what will happen? The blob will move along the circular arc. It will not fall down vertically because the motion is restricted, it is tied by a string. If there were no thread, then in that case the blob would have moved vertically in the downward direction. But it is tied by a string. So the motion has now become restricted. This is a constraint motion. The motion will execute along a plane of oscillation of the blob. Right? So instead of going directly in the downward direction, it will go downward but moving along the arc. When it is moving along the arc, still it is going in the downward direction because h decreases, but the movement is not vertical, right? It is simultaneously going in the horizontal direction as well as in the vertical direction. Means the resultant direction is not either vertical nor horizontal. So, when the blob is going in the downward direction, at any position on the path of the blob, path is the arc, at any position of the path, the blob has both potential energy as well as kinetic energy. It is now moving, so it has some velocity, and since it has some velocity, so it should have some kinetic energy. If velocity at that point is v, small v, and mass of the blob m, so half mv square is the kinetic energy, right? And if at that position the height is h means again with respect to the same datum, h means here say h1, h suffix 1, then mgh1 is the potential energy, then half mv square plus mgh1 is the total energy. And according to the conservation of energy principle, energy can neither be created nor be destroyed. It gets transformed from one form to another. That is the conservation of energy principle. And here in this case, only two forms of energies are there: potential energy and kinetic energy. Both are mechanical energies. So the summation of potential energy and kinetic energy will remain the same throughout the path or throughout the arc. Summation of the potential energy and kinetic energy will remain the same. So at the initial case, at the rightmost position here, this is my right hand. In your video, this is my left hand. Selfie is being taken today. So, here all the energies were potential energies because there was no velocity. So this potential energy will be equal to potential energy at this point plus kinetic energy at this point. This way you should use conservation of energy principle. This way you should use conservation of energy principle. Question is, what is the new height? All these things can be obtained from the geometry of the physical problem. Length of the thread. Say this is L. Here L means length of the thread plus that radius of the bob. Okay, that is the total length. That is called the length of the pendulum, not length of the thread. Length of the thread plus the radius of the bob is equal to the length of the pendulum. Okay, so length of the pendulum is L. Then that angle was taken to be theta. So using all these things, you will get the value of h, the value of h1, etc. in terms of L and theta. These are known to you. In this video, I am just going to show you the method of analysis. Okay. What will be the velocity? That can also be obtained easily. All these things I'll show you on board. Okay. Anyway, so this way you should approach to solve such problems. At any point, you calculate potential energy as well as kinetic energy. Here the motion is accelerated. Somewhere acceleration is present, somewhere retardation is present. That means somewhere it must have zero velocity. Right? Where it will get zero velocity, it will have zero velocity at the mean position. The lowermost position of the bob. There it will have zero velocity. When the bob is moving toward the mean position, the bob has acceleration. And when the bob is going away from the mean position, the bob has retardation. Okay? And the point at which there is no acceleration, there is no retardation means there the velocity is constant. That is the point of maximum velocity. Am I right or wrong? I am right. Because at the mean position there is no potential energy. All the potential energy has been transformed into kinetic energy. That means at that point the velocity should have its maximum value. And at the extreme positions, the bob will have minimum kinetic energy, and that minimum kinetic energy is zero. There is no velocity. Because at those points, the direction of velocity will change. Will be opposite, not only change, will be opposite. So, velocity should be zero. Otherwise, that change was not possible. Anyway, just verbally, mathematical analysis of this problem is not possible. Verbally, mathematical analysis of this problem is not possible. I have just shown you the technique, how you will approach to solve such problems. Okay? And ultimate result, you know that t is equal to 2 pi into root over of L by g, where t is denoted by capital T, is used. Capital T means time period, L means length of the length of the pendulum, small g is acceleration due to gravity. This formula is applicable only when that theta is less than 4 degrees. You can take this pendulum anywhere on the surface of our planet Earth, and you do the experiment, measure the time period, length is already known. Then by using that formula, you are able to measure the value of acceleration due to gravity at that place of the Earth. Because you know that at different places of the Earth, the value of g's are different. Value of g is different at different places of the Earth. Average value is taken to be 9.8 meter per second square. Okay? Okay. In next class I'll show you in next class I'll show you on board the mathematics. Mathematics involved here is very simple, but verbally it is not possible. Okay? You have to express those heights to measure the potential energy, to calculate the potential energy. Those heights you have to write in terms of that length of the pendulum, that angle theta, etc. And verbally that is not possible for me. For you it may be possible, but for me it is not possible. Thank you. I'll meet you again in the next class. Have a good day.